Okay, you should have, you're supposed to read section 3.1 in your textbook that starts on page 82. I gave that for homework last week. So I hope you did that. I'm not talking about that, so I hope you did it. So a lot of the stuff in this first section is review from Chemistry 1, okay? We probably know it. We're going to try and go through it a little bit faster so that it's just review. But by the advances of Dalton, Gay-Lussac, Lavoisier, Avogadro, and more scientists, we were able to calculate relative atomic masses for elements. So the modern system of atomic masses is based on carbon-12 as the standard. So this was instituted in 1961, so it's been around for a good 50 plus, almost 60 years. And carbon-12 has a mass of exactly 12 atomic mass units. So in Chem 1, we would label atomic mass units as AMU. Our textbook that we used for this year labels it with just a U. So either one would be fine for a unit label. And the masses of all other atoms are given relative to this standard. So carbon is our standard, and they figured everything else out based on that carbon-12. So we've heard of moles before. We will celebrate Mole Day in here. That's in October. It's equal to the number of carbon atoms in exactly 12 grams of pure carbon-12 isotope. So mass spectrometry, goodness gracious, I can't talk today, has been used to determine this number as exactly 6.02214 times 10 to the 23rd. Last year, we did 6.02. I think on the handout, it might be 6.022. I don't think it really will affect your answer, and you will get it wrong if you use 6.02 versus 6.022. It's up to you. I don't care which. But that is Avogadro's number, named after Amadeo Avogadro. Even though the definition contains carbon, this mole can be related to all other elements, like we have done in Chemistry 1. So some comparisons. Every single element has the same number of atoms present, but the mass changes. And so these masses are found on the periodic table. They are also known as the mass number or atomic mass there for you, but this table just has a bunch to compare from there. So thus the mole is defined as such that a sample of a natural element with a mass equal to the element's atomic mass expressed in grams contains 1 mole of atoms. That's where we get the unit grams per mole. Okay. So example 1, let's figure this out without using a mole map, because you're not allowed to use a mole map on the AP exam. Okay. So americium is an element that does not occur naturally. It can be made in a very small amounts in a device known as a particle accelerator. Compute the mass in grams of a sample containing 6 atoms. So to solve this, you guys remember the dimensional analysis, the parenthesis dividing stuff? What do we do first in the first parenthesis? Put the number over 1. So what are we going to put over 1 in the first parenthesis? 6 atoms, yep. Okay. Then we were just talking about atoms, and we have Avogadro's number, and that is equal to how many atoms are in 1 mole. So the conversion, we'd have 6.022 times 10 to the 23rd is equal to 1 mole. So those numbers are what we're going to plug into the second parenthesis. Where will Avogadro's number go? In the numerator or the denominator? We're going to put it in the denominator so that we can cancel out the atoms, and 1 mole will be in the numerator. Okay. And then you could do this whole like atomic mass unit deal, but we kind of know what to do. What are we going to do next if we need to know mass? What should we use next? Grams. And where does that grams come from? The mass on the periodic table. The atomic mass units on the periodic table. So That is how many grams are in 1 mole. So 1 mole will be in the denominator, so that we'll be able to cancel moles out. And we're talking about americium. Does anybody, what's the symbol for americium?
AC.
No. That's actinium.
AM.
AM. AM. So what is the molar mass of that? 243 exact?
Yep.
Okay. It's exactly 243 because it's man-made, so it's just an estimate. They have to have it be around for longer to do more tests to see if there's actual isotopes.
It's because it's American and people are.
Where is that? Where did you find it? Edmund, where did you find it?
The bottom section.
The bottom row, 95. 95 AM. So here's one that, okay, it's a good guess that it would be AC, right? But like on the AP exam, you're not going to have names, so AC would be a good guess if you get everything wrong. So kind of need to know AM, because most of the time it's the first and second letter. Okay, so did anybody solve it already? 421 times 10 to the negative. Negative 21 grams. Good? Everybody get that? If you need a review of scientific notation in your calculator, I can do that later. So now, in AP Chemistry, you do get counted off on problems for not running to sig figs. But when you have an exact number like 6, you don't have to run to sig figs. If you want to run to sig figs, you can. But in this case, there are cases sometimes where when you have exact numbers, it's not considered when rounding to sig figs. So on this problem, we'll just leave it like that. We won't round it for today. If we were to round it to 1 sig fig, what would the answer be? 2 times 10 to the negative 21st grams. Yep. Feel good if I move on? Okay. So example 2, we are going to just start with grams this time. So aluminum is a metal with a high strength to mass ratio and a high resistance to corrosion, thus it's often used for structural purposes. Compute both the number of moles and the number of atoms in a 10-gram sample of aluminum. What's the symbol of aluminum? AL. AL. Yeah. So we want to know moles and we want to know grams. So we're going to stop instead of going all the way through. Okay, so what do we put over 1 first? 10 grams. 10.0. So this time it's 10.0. That's an exact number. It's something we could actually weigh, so we will round to sig figs this time. Okay, what's the molar mass of aluminum? 26.93. Is that going to go numerator or denominator? Okay, denominator. Is anybody confused about why I just went automatically to molar mass?
Yep.
Because if you start with grams, you have to cancel grams away, and the way to do that is with molar mass. Okay? So we will divide by that molar mass of 26.98, right? That's what you get? Okay. I think I copied it wrong on my thing. Okay, and we want moles, so let's pause there and round and get an answer for moles. So what is the answer for moles? Say that again. 0.3. Thank you. So rounding to sig figs, that would be. Does the 0 before count? No. So it would be 3 significant figures because the 0.0 makes a 3. So 0.371 moles. Okay, that's one of our 2 answers. Now, we're going to move on to atoms from here. Remember, when you are moving on, you don't want to use the rounded number. You want to use the exact number to move on. So whatever you had in your calculator, leave it there for the next calculation, okay? You could just write down the rounded version on your paper so you don't have to write everything down, because that's a lot of work. But in your calculator, keep it whatever the exact number was, okay? So I'll just do that just to remind you. That's moles. Moles. Okay, and then to get to atoms, we will use what? Avogadro's number. And do we multiply or divide this time? We're going to multiply because we want to cancel the 1 mole out. And the answer is 2.23 times 10 to the 23rd atoms.
Yes.
Okay. Okay, so just to make sure, defining molar mass with our collection of atoms, the molar mass is the mass in grams of 1 mole. The molar mass of a substance is also known as the atomic weight or the atomic mass, and it's the sum of the masses of the component ions when you have a compound. Okay, so for example 3, calcium carbonate, which is also called calcite, is the principal mineral found in limestone, marble, chalk, and more. We are going to first calculate the molar mass of calcium carbonate, and then we're going to find the mass of the grams of calcium carbonate and the mass of just the carbonate ions present. So that's something different that we haven't done in Chem 1 before. Just a side note, whenever you have a free response question for Chem AP, we have long free response questions and short free response questions. The long questions, you only have 3 of on the AP exam, but they could be up to like 10 parts. But the parts could be like part 1, solve for molar mass. Part 2, solve for this portion. So it does sometimes try to just break up all the steps to the problem, okay? So do I need to show the math for molar mass? No, I'm not going to because we're going to save time. So what's this formula for calcium carbonate? CaCO3. Okay, and what's the molar mass of that? 100.09. Okay, that's right. Because your periodic table doesn't have all the like decimals, right? If you remember like carbon's 12.01115, you are more than welcome to still use that, even though your periodic table doesn't say that. It's okay. All right, so then we're going to use that for the first part of the second question. We want the mass of the sample when we have 4.86 moles. So 4.86 moles over 1. Do we multiply or divide by molar mass? Multiply. Remember, if you ever need grams, you're going to multiply. If you ever need moles, you're going to divide, since we can't use mole maps anymore. Okay? And just for rounding purposes, because also we will round to sig figs, you could just assume that it's 4.86 times 100, which would be 486 grams of calcium carbonate. Okay? And refresh from significant figures. 4.86 is 3 sig figs. So that's 3 sig figs. Okay? Molar masses, you don't have to round to sig figs ever, if you ever have to do that for the part. Okay. So now the other part of the second part is we want to know the mass of just the carbonate ions present. So this mass that we just found is the mass of calcium and carbonate together. Okay? So now we have to do something else to separate them apart. So I have to clear because I don't have space. Okay, so if we have calcium carbonate is CaCO3, there is 1 calcium for every 1 carbonate ion. Okay, so we can do like a little mole ratio 1 to 1 so that we can then find out the grams of the carbonate. If it wasn't 1 to 1, like if it was 1 to 2, then it would change it just slightly. Okay, so we're going to start back with our moles, because if we didn't, it would actually be more work. So we have 4.86 moles of the calcium carbonate. Then we are going to multiply for 1 mole of carbonate for every 1 mole of the compound. Okay, and that's because there's 1 carbonate in the ion, or 1 carbonate in the formula. Then, now, we are going to, since moles of calcium carbonate cancel out, now we're going to get it to grams. But this time, we're not going to use the 100.09 molar mass. We are going to use the molar mass of just CO3. And electrons are so small that you don't have to include them in molar mass. So, does anybody have figured out what the molar mass of CO3 is? 60.01. That should be 3 oxygens plus a carbon. And again, we're going to put it in the numerator because we want mass at the end, so we're going to multiply by molar mass. And what's that answer? Go ahead and round it. 292. So this is just another example of how we could use molar mass. We didn't really get into the ions side of things like this in Chem 1, but hopefully it's pretty self-explanatory. If you need more help, let me know. Okay. So the last part of section 1.1 is we just need to review problem solving. We talked about this in Chem 1 today, actually. So you're going to become a great problem solver. Woohoo! Remember, problem solving is not just like math problems, because that's what everybody thinks about. In order to think on your own, the example problems in this class are designed and explained so that you can relate back to these, but also take their concepts further. So there will be times that the homework problems include something that you haven't seen before. But the reason why we have that is so that you can try to think about it on your own and think about it further so that you will be ready for the AP exam in May. Okay? But I'm here to help you, so if you don't understand something, you just need to ask me. Okay? So although the examples are explained, it's crucial that you interactively think through the problem too. More tips are available in your textbook if you wanted to read more about problem solving. But hopefully I am a good leader in problem solving.